Welcome back to this channel. In this video, we are going to be talking about drawing the Lewis structure. Alright, firstly, we must understand what the Lewis structure is. The Lewis structure is basically a structure that shows the symbol of an atom and the number of valence electron that it has. The Lewis structure shows the symbol with the number of valence electron that atom has. Valence electron means the number of electrons on the outermost electron shell. All right, so recall your first 20 elements. For example, on the periodic table, we have the periodic table this way, so that of the first 20 elements, actually, so we have hydrogen here, helium here, and I have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, and blah 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 like that. All right, now how do you draw a Lewis structure? First, I said that it is the structure that shows how many valence electron an atom has. So, for example, let me pick carbon. For example, carbon has how many valence electron? It has 4 valence electron in its outermost electron shell. Wait, don't be dismayed on how I got that. It's very simple. Number one, if I have the group in which each element belongs to is the number of valence electron corresponds to the number of valence electrons it has. So if I am in group 1, I have how many valence electron? 1 valence electron. Group 2, 2 valence electron. Group 3, 3 valence electron. Group 4, group 5, group 6, group 7, and group 8. So they have those valence electrons. And an atom seeks to attain a stable duplet or stable duet or a stable octet. A stable duet or a stable octet. So in this case, it means that if I want to write for carbon, for example, carbon is in group 4. Because it's in group 4, it means it has what? 4 valence electrons. Now, the way you draw it neatly is by putting the dots around it first singly before you pair. Is that okay? So we have 1, 2, 3, 4. So all these 4 bonds shows this is the Lewis structure of carbon. It's as simple as this. All these 4 bonds show that the carbon can pair with another bond, with another atom in 4 centers. Is that okay? All right. Let me draw, for example, the Lewis structure of fluorine. Fluorine is going to be like this. F, is that okay? And I'm going to have 1, 2, 3, 4, 5, 6, 7. All right? Because it is in group 7, right? So you have 1, 2, 3, 4, 5, 6, 7. 7 electrons around it. This dot corresponds with electrons. So if, for example, this guy molecularizes carbon, or no, let's use a substance that can actually molecularize for chlorine, for example. If it molecularizes, it's going to have 1, 2, 3, 4, 5, 6. And I just quick eyeball that you're supposed to draw it singly before pairing, but since I know it's 7, I just do it directly. Now, if you want to molecularize another chlorine, now what you have is this. These electrons will come together like this. We have something like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. To show that there are still 6 lone pairs. Now, 3 lone pairs. Now, as it is this way, as it is, you call this lone pairs. You call this lone pairs. Now, as it is in this form, these 2 electrons, if you remember the video that in covalent, where I talked about the bonding, these 2 electrons will belong to this chlorine as well as this chlorine. Is that okay? So in order to show this electron, what we do is we basically just use a line diagram to show that these 2 bonds belong to chlorine, and this first chlorine and the second chlorine. So that when we are counting the number of electrons that this guy has, we're going to count 1, 2, 3, 4, 5, 6, 7, 8. So stable octet has been what? Attained. For this guy as well, we're going to count these 2 electrons as part of the electron to attain a stable octet. Is that okay? All right. So how about now to draw the octet structure of, for example, the Lewis structure rather, or for example, nitrogen, N2 gas. N2 gas. How do you draw the Lewis structure? Now remember that nitrogen likes to share 3 electrons with. So the bond between these 2 guys is a covalent bond. where both of them are sharing 3 electrons. The first one donated 3 electrons because it needs 3 electrons to attain stable octet. Is that okay? So to attain stable octet, since it needs 3 electrons as a group 5 member, it's going to share its own 3 with another nitrogen that has 3 to share as well. All right. So it means that it's going to coordinate with 3 bonds. It seeks to coordinate with 3 bonds. So you have N, 1, 2, 3, N. Is that okay? All right. So now let's see how many electrons that they now have. This guy now have 1, 2, 3, 4, 5, 6. Now, but this is not octet. How do we now have octet? After having this 6 for this guy, we're going to have 2 more. 1, 2 on 2 more electrons. So showing that what? That it has attained what? Stable octet. So we have 1, 2, 3, 4, 5, 6, 7, 8. Remember I said we count these bonds as electrons for this one guy and this second guy. So for this other guy to attain stable octet, we add 2 what? Electrons. So this is the Lewis structure for N2 gas. Is that okay? All right. Now, there are basic rules for drawing the Lewis structure. The first rule is this, that you should count the number of electrons. Now, after counting the number of electrons, you now determine which one will be the central, the atom that will be central, the central atom. Determine the central atom. Now, after determining the central atom, you now draw single bonds. Draw single bonds to join around the central atom. Draw it to join other atoms. Then, after drawing that, make sure that everyone attain a stable octet. Determine the octet forms of each of the bonding atoms. All right, let's see how to use that rule. For example, let's try to draw the molecule of water. Now, if you want to draw water molecule, what you simply do is this. What is the central atom? Now, first, we have to count how many electrons. Yes, let's count how many electrons. Now, how many electrons does this guy have? This guy have 2 electrons, so it's going to be 2 plus how many electrons? Valence electrons. And if you are not sure, this is how I calculated my 2. Just come to the periodic table. It's on what group? Group 1. 1 times 2 is going to be what? 2. 1 times 2 for hydrogen. Now for oxygen, how many valence electrons does he have? He's in group 6. So it's going to have how many electrons? 6 electrons. So we have 6 times what? Times 1. That's what? That's going to be what? 6. So we have how many electrons? 8 electrons. So it means that 8 electrons must appear in our compound. 8 electrons throughout must appear in our structure, in our Lewis structure. So the Lewis structure of water will be like this, therefore. We draw the central atom. So we identify the central atom. The central atom is the one that usually appears singly. So oxygen is 1 here, so it will be our central atom. We put it in the middle, and we draw to the first end and the second end our hydrogen. We always draw rightward and leftward, all right, not up and down for water. So now, it says that we should identify the central atom, and we have drawn single bonds towards each of it. Now, after drawing 2 bonds, let's see. This one, hydrogen seeks to attain a stable duet or a stable duplet. So let's see if it has attained a stable duplet. 1, 2 for this hydrogen is complete. 1, 2 for this hydrogen is complete. But how about oxygen? Oxygen seeks to attain a stable octet. Let's see if it has attained it. 1, 2, 3, 4. You know, both bonds are from oxygen. So it means that we are going to count the 4 electrons that make up this bond. Each bond contains 2 electrons from what I showed you here. So we are going to count the 4 bonds, count all the bonds here, and we're going to notice that there are 4 electrons there. So it means that this guy doesn't have a stable octet yet. It means how many more electrons? 4 electrons. It has 4 here, so we're going to give it 4 more electrons. 1, 2, 3, 4. And this is the Lewis structure of water. All right, let's draw one more before we end the video. We have SO3, for example. To draw the Lewis structure of SO3, what do? We said that we should count the number of electrons. Now, sulfur is on what number? It's on number 6. If I continue this, we're going to have phosphorus, sulfur, chlorine, argon. So sulfur is on number group 6. It means that it has 6 valence electrons. So we have 6 times 1 is equal to 6 for sulfur. Then for oxygen, it's also on number 6. All right, so we are going to have 6 again, times what now? Times 3, because there are 3 of them that appear here. So we're going to have 6 times 3, 18. So 18 plus 6, we're going to have 24. So it means we are going to have 24 electrons throughout. Notice here, we had a total of 8 electrons. How? 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons through. So here too, after drawing our structure, we must have 24 electrons apparent on that structure. So what do we have here? Let's identify, we've counted the number of electrons. Let's identify the central atom. What will be the central atom? The one that appears one, as we rightly said. So we're going to have sulfur here. So, and there are 3 oxygens surrounding it. So we're going to have oxygen here, oxygen here. We usually draw the next one up and here. Is that okay? So notice I've already drawn the single bond. So I've drawn single bond, drawn single bond, drawn single bonds here. Is that okay? All right. Now, let's now determine their octet forms. First, this oxygen needs the octet, the Lewis structure of oxygen is what? 1, 2, is number 6. So it's going to be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So this is going to be the octet, the Lewis structure of oxygen. So what it has done is, it has reacted with this guy with 2 of its electrons. So because it has reacted with 2 of its electrons, no, it has shared 2 electrons with this guy. You know, sulfur is also a number 6, right? So sulfur has brought its own 2 electrons here. So this guy is going to have 1, 2, 3, 4, 5, 6 to have a stable octet. So that when we count the number of electrons on this guy, we're going to have 1, 2, 3, 4, 5, 6, 7, 8. Is that okay? For this guy also, how many electrons are there? 1, 2, then it needs 6 more. 3, 4, 5, 6, 7, 8. Is that okay? Then for this guy as well, we're going to have what? 1, 2, 3, 4, 5, 6, 7, 8. So this is supposed to be the Lewis structure, but let's see. We have not counted for sulfur. Let's count sulfur if it has complete octets too. 1, 2, 3, 4, 5, 6. Now it means that it remains what? 2. Now if we draw 2 electrons here, it's not going to be stable, right? Because this guy is going to create a resonance structure. So what we are going to have at a particular point in time is not this. It is going to be that there will be 2 electrons. 2 of these electrons will come here. And when that happens, we're going to have the resonance structure like this. A double bond, and then this is going to be 1, 2, 3, 4. While the other guy is going to have 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And this is going to be the resonance structure of what? SO3. So you see what I did here? I basically brought these 2 electrons here, and then we have this. So at a particular point in time, what we are going to have, so it doesn't confuse you, let me clean this. What we are going to have is this. So at another point in time, what we are going to have is this electrons will move here, and we are going to have this again. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. So that for sulfur here, we're going to have 1, 2, 3, 4, 5, 6, 7, 8. All right. You see? And that electrons will still move from here again to this place. And so we have what is called a resonance structure. A resonance structure. Or we call it canonical structure. I'm going to link a video in the description where I talked about the terminologies that we use in organic chemistry. I also do well to see that video. I hope that you have known how to draw a Lewis structure. It's going to help you to understand how forces interact and how resonance structure actually take place in balancing some ring structures in organic chemistry. See you in the next video. Do well to subscribe to this channel if you have not, please. Do well to subscribe to the channel. It's going to help the channel grow, and of course, it's going to help reach other people when you subscribe. Thank you very much. God bless you.